Hey guys, welcome back to our third podcast. Well, welcome back to our podcast. This is our third one. I'm coming to you from Orlando, Florida. And Derek?
Hey guys, Derek here. I am coming to you from Melbourne, Florida.
Yeah, so last time we talked to you about, if you have an idea, how do you, the 10 steps to bring your product to life. Today, I thought maybe we could do a deep dive into product design and the different steps that we follow or you should follow to bring your product to life. And those are called the 3 VTs. Derek, what are the 3 VTs?
There are 3 VTs. There's PVT, EVT, and DVT. Not specifically in that order, but that's what they are.
Yeah. So actually, there's also one more step, and that's called the POC or the MVP. POC is basically a proof of concept, and I think that's the way you start a product. So you want to put stuff together, and I have some samples I can show you, but you want to put stuff together that conveys a message or conveys what your product should do or how it should function. And actually, I'll show you one. So here's something that I put together. It's basically just like one of these development boards, and then a shield, like an Adreno shield, and then I soldered on some wires and soldered on that screen, and now I can program it and put it together and show people, hey, here's my idea. That's what I call a proof of concept. It's definitely not something that you would take and sell to anybody because it's not ready for that. But you can take this to a product design company and be like, hey, I need you to help me put this together. So, Derek, what are your thoughts about proof of concept for like plastic injection molding?
I think if you're going to go to plastic injection molding, obviously you're not there yet. And coming up with a proof of concept, I always say you can start out with a clay model. You can, take Play-Doh and form it into your concept, what you think it is. And that makes it easier to communicate with whoever you're talking to. It could simply be popsicle sticks that are glued together. If you have a 3D printer and you're able to do any sort of like 3D CAD using some of the free software online, coming up with a proof of concept, anything available there to help communicate what you're trying to do, that's going to help a lot.
Cool. So once you have your proof of concept and you've shown it to a designer, the next step is the EVT. And the EVT is basically an engineering validation product. So the idea behind that is you want to go from something like this to a product that kind of resembles your PRD, or at least not kind of, like fully resembles your PRD. And again, I have some samples of that. The idea is each stage is like a cycle, and you enter the cycle, you get stuck in that cycle until you have met some exit condition. And in terms of EVT, that exit condition is that you can check off all the boxes of your PRD, which you wrote. And if you don't know what a PRD is, you can check out our last video. We talked about writing down all the features and list all the features that you need. You would hand that to a product designer, and then they would be able to design your product and use that as a way to check off all the different features. And then I have an example here.
So Jay, what you're saying is you want to start with a PRD and make a POC, and then you're going to be in the EVT. Is that correct?
Yeah, something like that.
Up to this point? Okay. So
yeah,
I just want to clarify.
It's really technical, and it's unfortunate, but hopefully, by showing things and showing you the different things, you can kind of understand like the process, the design process. So you start with the proof of concept. It's stuff that you just bought, put together. Then you move on to something that looks a little bit more like your product. And this thing is this is something that we take to like trade shows. And you can see, the plastic looks something like what the final product should look like. The PCB is no longer off the shelf. It's designed. Then you have a case. You got the motor, battery. So what I'm saying there,
Jay, that's an exploded view of a product, correct? And so on the top, I see something blue. On the bottom, I see something blue, and then the circuit board. So it's kind of it's a product that's exploded, and it's in that sort of case, so you can kind of zoom in and see, right? That's what you're showing us?
Yeah. Okay. So when we built this, you can put it together and it would actually be a final product that you could actually use. And in this case, this is a Wi-Fi button. So you click it and it reports back using Wi-Fi. So So basically, you're kind of stuck in this stage. Your designer's stuck in this stage, and you're designing the product, and you're making sure you're checking off all of these different things. And for this example, would be like battery life. It has a button, or maybe it has multiple buttons. Is the size about right? Is the dimension right? Does it look right? And once you've checked all those boxes, then you can move on to the next phase. So what's the next phase?
DVT, which is your design, validation, and testing.
So at this point, you want to be, you're past that PRD. You've got the product, and now you want to make at least 100 of them. So if you want to make 100 of something, you could definitely 3D print it, but it's probably not recommended. It's better to actually build the product the way it would be built in a manufacturing setting. And so for that, we would recommend something like an aluminum tool or a steel tool, which could easily make you how many? 1,000 units, a couple thousand units, Derek? What's an aluminum tool give you?
An aluminum tool, I mean, seriously, you can get 1,000, 5,000 units. That's no problem. You could also do a silicone mold too, urethane mold. That will kind of get you maybe 20 to 50 units maximum. And that gets you
would you really, I'm not sure you'd want to use that for design validation.
That's
silicone mold would probably be better for an EVT where you're not so worried about testing and FCC and CE and UL and all that stuff. For design verification or validation, you want to have the product be as close to the real product as possible.
True.
So in that case, I would say probably want to use some kind of tool.
And so if you're going to use an aluminum tool, like you said, you could do 1,000, 5,000 units easy. Once you start going beyond those numbers, the tool itself, it becomes kind of questionable whether you're going to get the product or not that you want. It might be degrading a little bit.
Right. So you make this tool, and how many do you make? I mean, that's a big question, right? Like, how many should you make? And our recommendation is at least make 100. I think after you make 100, you can really test your product and make sure give them to some people, make sure it's actually working the way you intended. I think 100 is a pretty good sample size. That's what we recommend. And then with that 100, you can start doing some tests. And examples of tests, drop test. Derek, is that your favorite test?
Yeah, we have a drop testing machine, and it has this little claw that opens and closes, and then we have all these cameras that start snapping pictures and recording as soon as it drops. So that's probably one of my favorite tests. Yeah.
And is there like a standard for drop tests? I mean, I'm pretty sure, like, isn't there like a height and like what you drop on?
Yeah, so there are standards that identify.
Where do you find all these?
My best friend, you just type in Google and type in what you're looking for. There are standards for what you're looking to do. Typically, it's like 1 meter, but it depends on what you're testing. And the drop platform, it also calls out what type of material it should be dropping on. Sometimes it's like plywood. It has to be a certain thickness. So basically, when that device impacts, it's something that is repeatable, and there's an industry standard so that you can make sure that what you're testing here is the same thing that you're testing, in New York and North Carolina and California. It's all the same test parameters.
Cool. And then some of the other tests that I have written down here, water resistant testing, not waterproofing, because like nothing is waterproof. Water will get in at some point. Scratch testing, I actually had no idea about that. I know Derek knows a lot about scratch testing. Derek, is that like a tool kit you buy on Amazon to like do scratch testing?
Scratch testing? Yeah, you're talking about like Mohs hardness. Yeah, for sure. So you can go to Amazon, type in MOHS, I think is the spelling, Mohs hardness. And then there are basically 9 little pencil-like devices. And on the tip of every single one of those, it has a different material. Now, of course, you're not going to get number 10, which is like what, a diamond? That's the hardest material. But you'll get, just under that. So you'll get 0 through 9 or 1 through 9. I forget the number. And basically, you can take those little tools at a certain angle. I want to say 45-degree angle, and you just scratch the surface. Of course, if you're scratching like plastic, well, you got to be careful with how hard you actually push versus, scratching, someone's car. It's just kind of different.
Got it. So scratch testing, I mean, that's a cosmetic thing, and I think that's definitely really important to get right in your design validation, material, cosmetic, make sure the product looks and feels the way it should. Make sure it scratches the way it should. And then the next thing to do would be to go get it certified. And again, that's kind of why you want to make the tool, because FCC or CE, they want it in the exact form that it will be shipped to your customer. FCC, CE, UL, those are tests that we've done on a lot of different products. And after you've passed those tests, I mean, that's the holy grail. It's like you've done all your testing, you've approved everything, you've made a couple hundred units, and so basically, after you finish this phase, you have confidence in your product. I mean, that's the exit phase, or that is the exit condition of this phase. And with that, maybe I could share some stories about what happens with people who skip this step. A lot of people bring a proof of concept and they're just like, hey, just manufacture it. It's ready. I don't know how many times people have come to us and said, hey, it's ready to go, just go make it. Tons of different stories. And it's basically, if you skip the DVT, you are basically rolling the dice. It's going to end up costing you more. You're going to have a lot more RMAs, a lot more unhappy customers, and it just sucks to be stuck in that negative feedback loop with customers and things like that. So I know there's some information floating about mixing the stages, like the DVT and PVT, and I think it's called XVT. Have you heard of that one, Derek? XVT?
No, I haven't, but it sounds crossing the two, that would make sense to me, but I actually have not heard about a cross VT or anything like that.
Which I think makes sense. If you have a low budget, definitely mix the two and make sure you do some kind of testing, at least in the field where you're going to be selling your product, so you know what could happen to your product.
It's also really important to get customer feedback during that design area as well, because the customer might tell you that button is too small, or it's too big, or the force is not enough, I need more force, right. Or I'm having water ingress in a certain area. So skipping that step, again, we can't emphasize enough how important it is to stay and make sure you go through that step and make sure you identify and do the testing that you needed before you go to the next stage.
Cool. So the next stage, now that you have the confidence to build your product, is PVT. Derek, what's PVT?
Production, validation, and testing. Don't forget the testing part. Everyone thinks you produced it and it's just magically going to work. Don't forget that testing part.
Yeah, so testing is baked into every single step. It's like you have to test, and test, no matter what you've done. Even after you've made your pilot run, you still have to test with your pilot production run to make sure that the manufacturing is done right, and to make sure that manufacturing doesn't reveal something that you didn't see before. That's happened many, many times as well. And again, a lot of people skip this step, which is really silly, right? They go from DVT, which is 100 units, to 5,000 units, and they just completely skipped 1,000 or 2,000. And now all of a sudden they have 5,000 units that they have to open, and they have to change a resistor or something. They have to change the battery, or they forgot, during manufacturing, there was a little line inside, maybe, Derek, injection molding line. Have you remember that kind of story?
I don't remember that, but I'm in my head, I'm thinking when we're doing circuit board assembly, we always run a few units and test to make sure that they work, because for whatever reason, the company could put a diode in your reel backwards. And so, diodes being directional, you might run all 5,000 units, come to find out when you go to do testing, they don't work. So we always try to run some test units, but customers are always pushing us to go faster. And, we have to really kind of stop the customer, because they don't know what they don't know. And doing those checks might cost us a day, 2 days, 3 days, depending on what we're doing. But it's going to save us a lot of time in the long run, especially if we've manufactured whatever number, 5,000 units, and now we have to go rework 5,000 units manually. That's going to take a lot of time.
Mm-hmm. So, again, a lot of customers ask you to skip this step, and we're very hesitant. And every single time that we've skipped this step with making 1,000 units, it's always come back, right? All those units come back, or get a really angry customer. So again, do not skip your pilot production run. That is your absolute last opportunity to catch any problems and to optimize your speed, your quality, and your cost. So that's 100%. That's something you want to focus on. And then the exit condition for your PVT would be you have mass-produced goods and you're getting really great yields. At that point, congratulations, you can sell your product and you don't have to worry about them all coming back.
You mentioned, about getting great yields. You might be manufacturing 100,000 units. One thing I kind of want to mention are the defects there too. I know this is kind of off subject a little bit, but what would be a good defect rate? It depends on what you're making. And going from 2 to 3% would be a good defect rate. Sometimes 5 to 10% could be a good defect rate. That depends on what you're making. But keep a look at that and keep an eye on that, because everyone looks at the production, but they always forget about the testing. And don't forget, if there are defects, you're going to have to account for that. So if you're trying to get 1,000 units made and your defect rate is 2%, well, you're going to have to make 2% extra at that point if you're trying to deliver 1,000 units, on the dot. That's really important to plan for that as well.
Cool. So just as a recap, start with your proof of concept and move on to your EVT and then your DVT, which unfortunately I don't have for this product right now. And then you can go into manufacturing. And I think manufacturing, you can, most of the time manufacturing you're not doing in the US, or sometimes you aren't, so you're not there. And so you really want to work out all the kinks before you send your product off to manufacturing. Is there any more stories you'd like to share, Derek? Any products you can think of that would be a good finishing touch?
There are a lot of products, but honestly, I think the biggest thing, if you to take away anything from watching this today, and that is to make sure that you perform tests at every stage. And I say set test parameters and set programming parameters and test to make sure that works. If you're working with any manufacturer, the biggest thing you can do is give them testing guidelines, whether it's a go, no-go device, a gauge that's going to measure the diameter of something, or a battery life, or a longevity test, or a distance test, or a water submersion test. No matter what it is, you can communicate that to your manufacturer, provide that to them, and make sure that it's testing accordingly, and make them do the testing for you, and then give them a request for documentation. Say, hey, I need you to document, every so many units. I think it would be a little bit unfair to request them to test every single one, unless, for example, you're doing medical devices and you're ISO 13485 and you have to provide a serial number for every single one. So that's important. Give a request, whether it's a template or something spelled out of what you're looking for, and then ask for this documentation from them. But it's a little unfair to ask for every single one to be tested, maybe 1 out of every 100 or something along those lines for those test parameters. And that's for a full assembled unit too. That's not, all the subcomponents and full assemblies. Of course, your full assembly, you do want to test. That's going to be pretty important.
Cool. Well, this time I actually do have a takeaway, and that is don't skip a step. I think I've said it enough times. And that's pretty much it for today. Be on the lookout for a blog post. We're going to write about this as well. Next week, we plan on covering a little bit more of the manufacturing process. I mostly do electronics. Derek does plastics. So maybe we can, pick one post on each one, just talk about the individual steps involved in that. And then we can switch to something else. So hope you've enjoyed this. Like, subscribe. If you haven't seen our other videos, check those out. And we are excited to see you next time. Thank you.
Bye-bye.